Okay, next step, price elasticity of demand. This is the most important elasticity concept that we're going to have, and so we're going to take some time walking through this particular measure. Now, when we talk about sensitivity, how much does demand change in response to price, which is what sensitivity is referring to, we could look at the slope of the demand curve. Okay, the demand curve itself is giving us a kind of measure of sensitivity because it's telling us how much does one variable change in response to the other variables. And taking the slope of a demand curve is giving us kind of a sense of the sensitivity of demand. However, the problem with using a demand curve is that we measure things in different markets in different ways. So sometimes, if we're talking about steel, for example, we might measure that in tons of steel, or maybe even some other measurement, kilotons, for example, or something like that. And soybeans, we might measure in bushels, or we might measure it in pounds. And we can switch the units that we measure things in. So we could measure soybeans in kilograms, we could measure them in pounds, we could measure them in bushels. There's lots of different ways of measuring the units of the individual items that are being produced. And if we just look at the slope of an individual demand curve measured with different units, it's going to be impossible to compare the sensitivity of demand across different markets and across different products. So economists have solved that particular issue or problem by creating this concept called elasticities. And what elasticities are going to do is use percentage changes in prices and demand. And then percentage changes are going to turn this measurement of sensitivity, it's going to make it a unitless measurement, meaning it's going to have no units associated with it. But it's going to tell us how sensitive demand of the product is to changes in the price itself. And by creating the elasticities, it's going to allow us to make the sensitivities comparable across different products that we might wish to consider. And that's one of the reasons for doing it in this more general way. All right, here's our definition. And I'm going back to, like we did a hand-drawn map at the beginning to talk about maps. Well, here's my hand-drawn notes that I've been using for several years. And I realize this is very hard to get all of this notation onto a PowerPoint slide. So it's a whole lot easier to just project the hand-drawn version. So here we go. So first, price elasticity of demand. That's our first concept and the first definition I'm giving to you. And in this first instance up at the top, PED, it gives us basically the definition of the concept. It tells us what it is we're trying to measure and specifically how. So the price elasticity of demand is a ratio. And the ratio is on top of the numerator of this term. We're going to put the percentage change in quantity demanded. Now let me introduce some notation. This term here is delta in Greek terms. It's a Greek letter. And delta is equivalent to saying this is the change in something. Change in. So when we want to change a particular variable, I'm going to use the term delta. And if we want to talk about percentage change, then we put these two together and say percentage delta is the percentage change in the quantity demanded. All right, so learn that notation if you don't know it already. Secondly, we're going to take that divided by, we're going to look at the percentage change in price. Now, looking at percentage changes, that means that there has to be a before price and there has to be an after price. There has to be a before quantity and there has to be a after quantity. And then we're going to look at how the quantity and price changed. This will be moving down along a demand curve to calculate this ratio and to construct the price elasticity of demand. Now, the other element in this particular definition here is the fact that we've got these bars here, the absolute value signs. All right, and this is a little bit different ways of presenting and talking about elasticities of demand. In this class, and for our purposes, I'm going to always want to consider the price elasticity to be a positive value. And to get it positive, we're going to make an absolute value, so we're going to change any negative value into a positive value and present elasticity of demand as a positive number. Now, I want to emphasize this because if you look in some other textbooks, or you go online and you're searching for price elasticities of demand, it seems to be true that some textbooks present this as a positive number, some textbooks present it as a negative number, and so you're going to see that variant out there. It's a little bit confusing, but it shouldn't be too much. And just keep in mind that we're going to abide by the positivity rule here and just keep elasticity of demand a positive number all the time. Now, why does it come out negative, though? It comes out negative because the demand curve, remember, we've got the quantity on this axis, we've got the price on this axis, and the demand curve is a negatively sloped line. So if you change the quantity in a positive direction, the price is going to move in a negative direction, right? It's going to move opposite to it. So if we did the percentage change in quantity versus the percentage change in price, it will come out to be a negative number because the demand curve is negatively sloped. So get rid of the negativity, just make it positive, and that's how we're going to apply and use this particular term. All right, now, formulas. There's a couple of formulas or a couple of different ways to derive elasticities of demand. And one way is to go up to the demand curve. Look up in the upper right, I'm playing with my little hand-drawn diagram here. Suppose we have 2 points on a demand curve. So one way we could calculate the elasticity between A and B is we could calculate or figure out from a demand curve, well, what is the change in price, quantity here, and let's compare it to the change in price in percentage terms as we move down from A to B. All right, so we could find our initial value is at A, we've got a price, we've got a quantity. Our new value is at B, we've got a price, and we've got a quantity. So we could calculate the percentage change in quantities and prices, form the ratio, get a measurement for elasticity. Okay, there's a problem with that approach, though. And the problem is that if we calculate the elasticity in this direction, we get one number. And if we calculate the elasticity moving from B to A, we get a different value for the elasticity of demand. And that's a problem because then it's like, well, what is the elasticity and at what point are we supposed to be calculating it? Now, your friend taking other economics classes might then learn this complicated formula, which is called a midpoint formula. And that's a way of sort of solving this particular dilemma that I'm describing here. All right, now I've just told you a little background just in case you come across this concept somewhere else. Here's how we're going to do it. We're going to solve the problem in a different way. All right, and the way we're going to solve that issue of moving from point A to B, I'm going to present you a formula for the price elasticity of demand that occur at one single point on the demand curve. All right, so we're not going to do a percentage change from A to B and kind of calculate that traditionally like that. We're gonna narrow it down and say, if we were really to focus our attention just at point A, how could we calculate the elasticity at a point? Now, the answer to that question turns out to be we could use calculus to do that. And it's very easy to derive elasticities and to talk about this by using calculus and taking derivatives. Now, derivatives are related to slope of a line, and derivatives are useful especially when and necessary when you've got lines that are curving and changing their slope. Straight lines, linear demand curves, have a constant slope, and it's going to make it a lot easier to calculate price elasticity of demand using this calculus formula. Now, I've used the word calculus a couple of times. That might scare people. Don't worry, we're not going to be using or applying calculus. I'm going to give you the result of that calculus exercise, and then you just need to learn how to apply that particular formula to calculate elasticities of demand at a single point. All right, and that's how we solve this problem that I was presenting up here on the upper right. All right, so what's the formula? It's down here. Price elasticity of demand is given by delta QD, this here, okay, and delta means now change in the quantity demanded divided by the original quantity demanded, all right, and that is just the definition of percentage change, okay? So we're putting percentage change of the quantity demanded on the top, and we're going to put delta P on the bottom divided by P. That's a way of measuring the percentage change in the quantity price, all right? And again, we got the absolute value terms listed there. Now, we can take this formula and we could rewrite it. And I'm going to do that here. So we're going to write delta QD divided by QD. So that's just the numerator brought over here to the right. We're going to take the denominator, which is a fraction, and we're going to use the fraction rule. We're going to say, well, if you're dividing by a fraction, you can take that fraction, flip it around, multiply the bottom part on the top, put delta P on the bottom, and that's going to be equivalent to what we have here on the left. All right, so now we've rearrange these terms. And now I'm going to rearrange them one more time. I'm going to move the delta P over to the left-hand side of this expression, move the QD over to the right-hand side. So I end up on the right here with P for QD. That's these two terms just moved over. And then, since I've got delta QD divided by delta PD, I could form the ratio in this way. I'm going to make it delta P over delta QD. And notice, if I do this, watch on the left-hand side here, I'm going to show you something. So if I take delta QD divided by delta P, this is equal to 1 divided by delta P divided by delta QD. Okay, and we can figure that out or note that the reason these are equivalent to each other is because I can take this denominator term and I could flip it around and multiply it by the top. So it's going to be delta QD divided by delta P. Sorry, my handwriting is terrible this morning. And it's going to become equivalent to what we've got there. Okay? So the reason I'm making that adjustment is because I want to be able to express this as the right-hand side term over here, the slope of the demand curve. So if we put delta P, if we've got a demand curve, look on the upper right again, we've got the quantity demanded, we've got the price, we've got a downward sloping demand curve. All right, well, the slope of this line moving from a point like A to B is going to be given by delta P, that's the rise, divided by delta Q, that's the run, and that is the slope of the demand curve. But we've got to have delta P on top because that's what's measured on the vertical axis, and we've got to have delta Q on the horizontal side. You've got to write it this way in order for it to represent the slope of the demand curve. Okay, so now, since we know this term is written as the slope, we can write the expression for the formula as 1 divided by negative of the slope, since the slope is technically a negative term, and this will make it positive, times the price that prevails at a point like A, that'll be this price, divided by the quantity that prevails at a particular point like A, that's the quantity. And now we don't worry about B. We don't care about another point on the graph or calculating the percentage terms between them because this slope is what's going to give us that information. All right, so you need to remember a couple of things here from the formula. You need to remember this general definition of what price elasticity of demand is, and you need to remember the specific formula that can be used to apply the price elasticity of demand with information from a demand curve. Okay, so let's see how we apply and how this. First of all, some definitions. If the price elasticity of demand turns out to be a value that's greater than 1, then we're going to say that demand is elastic. And elastic is a synonym for sensitive. Okay, so demand is going to be sensitive if PED is greater than 1. If PED turns out to be less than 1, we're going to say that demand is inelastic. And that's like saying it's not sensitive or not so sensitive to the changes in prices that prevail in the marketplace. All right? And that's going to be our kind of our borderline definition of what's sensitive and what's not so sensitive is the value of 1. And remember, if the value is 1, we're down here to the third term, then we're going to say that demand is unit elastic. But what it means then, if that value is 1, is that when the price changes by 1%, well, then the quantity demanded is going to change by a similar 1% as well. All right, those two are going to be equal to each other. And there's a sensitivity there, but it's a unit. It's a 1-to-1 sensitivity. And we're going to highlight that as another terminology or definition. Now, in the extreme case where the price elasticity of demand is equal to 0, we're going to say that demand is perfectly inelastic. And notice, less than 1, it's inelastic. If it gets so less than 1 that it gets to the limit, which is going to be 0, can't go below 0, we're going to say demand is perfectly inelastic. And vice versa, if price elasticity is such a big value, it's so much larger than 1 that it approaches infinity, well, then we're going to say that demand is perfectly elastic or enormously sensitive, you might say. All right, so that's what we're trying to get at with this measurement of sort of defining different levels of sensitivity of demand to changes in the price of the product itself. Okay, let's do some examples. So here's a question to all of you. Here's the simplest question I can ask you. If coffee demand rises by 10% when the price of coffee falls by 5%, what's the price elasticity of demand? Think about it, write down an answer for yourself. And that's going to be exactly right. Because what we're going to do is we're going to just form the ratios of the percentages. We put 10% on the top, we put minus 5% on the bottom. We take the absolute value to make sure that that value is positive, and we end up with the number 2. Now, I want to think a little bit about, let me go back to this formula. And I want to highlight something about this formula again. Okay, let's think about the units of this price elasticity of demand. How would we measure this particular thing? If we look at the formula over here on the far right, we'll note that the units of these things is 1 divided by the slope of the demand curve is going to have price, which is going to be dollars per pound on the top, divided by the quantity, which is going to be in pounds. And then we're going to multiply that by a variable price, which is dollars per pound, let's say, and we're going to divide by the quantity, which is pounds. Now, if we take this and turn it around, that can be written as pounds divided by dollars per pound, LB, and that's going to be multiplied by dollars per pound divided by pounds. And what happens is that these cancel out, and the units don't exist. There are no units to this particular expression. It's a unitless value, all right? But it is a value that we interpret by saying things like, we can look at what the ratio is looking at. It's telling us that quantity demanded is going to increase twice as much in percentage terms when there's a particular change in the price. All right, so we're getting at the sensitivity, but we're not using any units. And that gets us out of the problem of different products being measured with different units. All right, next question. Suppose the price elasticity of demand is 0.5 for a particular product. If the price of coffee were to increase by 10%, and we knew the price elasticity of demand is 0.5, then calculate this. What would be the percentage change in the quantity demanded as a result of that 10% increase in the price? Figure it out, write it down, see what you get. Okay, 5 is the popular answer. Let's see if that's the right. All right, now here you're going to have to do a little bit of manipulation maybe, because, or at least thinking about how to present the answer. So you're not being asked for the price elasticity of demand, you're asked for the percentage change in quantity. All right, so that means you're going to use the PED formula, percentage change in quantity over 10%. That's 0.5, I plug that in for the price elasticity of demand, that's what I've gotten up here. And then I don't know what the percentage change in quantity is. I'm going to divide it by 10, though, because I've got a percentage increase of 10% here. All right, that's going to give me 10 times 0.5 is going to give me the 5, and that's going to be equal to the percentage change. But now we want to throw in that negative sign, because we know that the demand curve is negatively sloped. You use the price elasticity of demand given to you as a positive value, but when you present the percentage change in quantity, you're going to want to present that as a decrease. Price of coffee goes up, quantity demanded has got to go down. There is a negative relationship, and you should display that there. So that's a little bit of a trick that you have to keep track of. Question, do you ever change the percentage into a decimal? You can use decimals as well. So if you were to plug this formula in and not do it as percentage, but just did the decimals, as long as you keep it consistent across the percentage change in price and the percentage change in quantity, you're going to come up with the same answer. So it doesn't matter which way you do that, actually. All right. Here's another kind of problem you might be presented with. Suppose you have a demand curve, and you've got different specified on this particular demand curve. So notice, if the price is $10, the demand for this particular product, and you'll notice I'm not even mentioning what product it is here. You know, maybe the product is coffee, or maybe the product is tea, or maybe it's steel, or it doesn't really matter. We just need to have some specific product that can be described and have a demand curve associated with it. All right, and here we're just doing it for illustration. So again, it doesn't really matter what product we're talking about. But if the price for this product were $10, this demand curve would tell us that the demand would be 0. If the price were $7, the demand curve tells us that demand would be 300, and then you got to look at the units. It's going to be pounds. Now, this is measured as dollars listed here, but technically the price is in units of dollars per pound. It's important to remember that it's not just dollars, the price, it's dollars per unit of the good that you're purchasing. All right? So now, if the price were $2, the demand would turn 800 pounds. Okay, and if the price were 0, then the quantity demanded would be 1,000 pounds, which is listed over here on the far right. All right, so we've got our bearings. We understand what the demand curve is telling us or what information it's giving us. But given this demand curve, I could now ask you this question. Calculate the price elasticity of demand at the point A. I'm going to give you a minute or so. Write it down on a piece of paper. Use the formula that I just presented. See if you can come up with an answer. And then I'll show it to you. I see a bunch of 7/3. I don't know what the answer is because I haven't looked at this in a little while. But I'm going to show it to you in just a minute. Let me just point out one trick, and that is, just before we get to step, is you want to calculate the slope. You're going to need to calculate the slope of this line. And to calculate the slope, I suggest you always, instead of trying to create what the equation of this line is and using the m in the y equals mx plus b formula, that's one way you could go. But the easier way to go is always to calculate the slope as the rise over the run between two different points on a demand curve. So you just need to have values for 2 points like A and B, and you can calculate the rise over run. So the rise in this case is going to be 7 minus 2, that's 5. And the run is going to be, well, here, 800 minus 300, that's going to be 500. So you could use that as your rise over run, and take note again, the slope is negative. And that would be a way of calculating the slope of the line. Or you could choose this point here, the 10 and the 1,000, those endpoints, and you're going to end up with exactly the same slope. So as long as you've got 2 points, you can calculate the line. All right, now, let's formula. Here's how we evaluate it. Price elasticity of demand is equal to, and here's the numbers plugged into the formula. Now notice that I've got the slope here written as 10 divided by 1,000. So what I did is, in that formula, is I used this point as my initial point, call it W, and I used this point, well, we'll call it D because there's a D there. The slope between W and D, the rise is going to be 10 units, 0 to 10, so that's the 10 on the top here. And the 1,000 is the 0 to 1,000, which is the run, and that's the 1,000 that's on the bottom. Okay, so I've chosen those two. But if you did the 7 minus 2 and the 800 minus 300, you're going to end up with exactly the same value. Won't matter which one you do, because a straight line has the same slope everywhere on it. Now, we're going to plug in the values of the price of the product at point A, and that's going to be $7 per pound. We're going to divide it by the quantity at point A. That's going to be 300 pounds. And we rearrange it. So 1 divided by 10 over 1,000 is going to work out to be 100. And we're going to multiply that by 7 over 300. That's going to give me 1/3 times 7. Notice I've taken the 100 divided by 300, gotten rid of the zeros, and that gave me the 1/3. Multiply it by the 7, and we end up indeed with 7/3 as the answer. Now, the next question I might ask you about that, and you could present it as 7/3, that's fine. You could present it as 2 as 1/3, that's fine. You can present it as 2.33, that's fine. Any way you present that is a correct answer to the question. If you ended up with 14 over 6, though, which is the same as 7 over 3, I would prefer you simplify that to 7 over 3, or write it as a decimal like this if you so desire, okay? So try to simplify your expressions as best you can, but you can leave them in fractions if you so desire. You can write them out as decimals if you so desire, and we'll accept either of those as answers. Now, the other question that might be asked about it is, at point A, is demand elastic or inelastic? And here, because PED is greater than 1, demand, of course, is elastic. And that's our definition of elastic demand. Okay, next question. Do it again. What's the price elasticity of demand at B? You will notice, I hope, that at point B, the slope is exactly the same as it was at point A. So you don't have to change that number in your calculation because it's going to be the same at A as it is at B. It's the prices and quantities that are going to change. All right, here we're going to write it. I simplified that 10 over 1,000 here, and I made it 1 over 100. You know, you can do that. That's why that number looks different than it did in the previous formula. But 1 over 1 divided by 100 times 2, which is the price, by 800. I'm going to simplify that to, let's see, that's 100 over 1. So 100 divided by 800 times 2. And you can rewrite these in different ways to work towards simplification. This is just the approach I'm taking. That allows me to get rid of these zeros and write that as 1/8 times 2. And then that's going to be 2 over 8. But again, simplify this, go to the next step, and get to the 1 over 4. And then you're going to end up with, you could write it either as 1/4 or 0.25 is perfectly fine. Okay, so this, not okay to present. This is better. Okay, what is it, elastic or inelastic? Well, here, because the value is less than 1, we're going to define or call that, at that point, that demand is inelastic. All right, now here we get an interesting or intriguing result, namely that as we've looked at 2 points on the demand curve now and calculated the elasticities, we determined that the elasticity is not constant at different points on the linear demand curve, that it actually changes as you move along the demand curve. So we're going to have some reason to investigate that further in just a second. Let's see what my next slide is. All right, so here's what we've learned just from that simple exercise. For a linear demand curve, again, straight line demand, price elasticity of demand is decreasing as you move down and to the right along the demand curve. And we saw that by the fact that our first elasticity of demand up here was 7/3, and then it fell to 0.25 as we moved down to the right along the demand curve. So elasticity falls along that demand curve. And that's going to be true. You could calculate other points along that demand curve. You're going to find the value continues to fall as you move from left to right along the demand curve. It's going to turn out that the price elasticity of demand is unit elastic, equal to 1, at the midpoint of the demand curve. Okay, so if we go back to this demand curve and say, well, okay, well, where's the midpoint? The midpoint is going to be at 500 units quantity, and it's going to be up here at a price of 5. Okay, I can just take half of 10 to get my price midpoint, and I can take half of 1,000 to get my quantity midpoint, and that's going to be my midpoint right there. And at that particular point, PED is going to be equal to 1, unit elastic. All right, so anything lay, notice, is to the left of the midpoint, and so it's in the elastic range, greater than 1. B is to the right of the midpoint, and so it's in the inelastic range. And this is a rule of thumb you can apply. So if you're given a demand curve, for example, and you're told, you know, is this point B, you don't have the numbers, but is this point B, and you know it's to the right of the midpoint, is that point inelastic or elastic? You should know from this exercise that it's going to be inelastic at that particular point, and elastic at A. So you might not have the numbers sometimes to actually calculate the elasticity, but you might still be able to tell whether an elasticity is elastic or inelastic at different points on a linear demand curve. All right. Now, here's a demand curve. Based on what I just said, the midpoint is right here, right? The red segment of the demand curve then is going to be the elastic segment. So that's to the left of the midpoint. Any point on a linear demand to the left is going to be elastic. Any point on the blue segment of the demand curve to the right of the midpoint here, call it M for midpoint, to the right of the midpoint is going to be inelastic. Okay, and the midpoint again is unit elastic, just like we said. But I want to introduce one other issue here that's going to come back, and we're going to use this principle or concept and apply it a little bit later in the course. Okay, and I want to highlight the fact that from the demand curve, we could identify how much revenue is being earned at different prices and demands that might prevail in the marketplace. And here, let me point out something else about this whole exercise. And I should have mentioned this earlier, but I'll mention it now. Demand curve is like a hypothetical. It's not actually telling us what the price is in the market or what the quantity, will turn out to be. It's telling us different hypothetical outcomes that may or may not come about. But it's telling us if the price is up here, for example, at P1, then the quantity demanded in the market will be at this quantity level, Q1. But it doesn't tell us that the price will be P1. I mean, I have to specify that to you first. And later on, we're going to come up with ways of deriving what the price will turn out to be in a particular market situation. All right, and as an example, later on, we're going to draw an upward sloping supply curve, and then the intersection of supply and demand is going to determine what the price will turn out to be in the market. But for now, we're not quite there yet. We're not actually trying to derive exactly what the price will turn out to be. We're just doing hypotheticals. All right, so hypothetically, if the price were P1, then the quantity demanded would be Q1, and we could ask, well, what would be the total revenue that could be earned on sales of Q1 at a price of P1? Well, revenue is just, I've got it written here, revenue is just the price times the quantity. So what we're going to do is we're going to take the price, that's the vertical distance here, times the quantity, which is this horizontal distance. And remember, we're measuring these values from 0, which is over here. So when we're talking about the price, we're actually referring to a distance on the graph right here, this distance. And when we're referring to quantity, we're referring to this quantity distance right here. And if we're taking the product, well, guess what? The revenue is given by the area of this particular rectangle. Right? So that's where we're representing, and we could find the actual revenue that might be earned if quantity Q1 were sold at a price P1, and that would satisfy all of the demand in the market if the price were indeed P1. So that would be revenue. Okay, well, what would happen if the revenue changed? I'm sorry, if the price changed? Let's say the price were P2 instead. The quantity is going to be Q2, right? And so if the price were to fall from P1 to P2, and we were to ask, well, what's going to happen to revenue? Revenue is now going to become equal to this blue box here. It's going to be this price, P2, times this quantity, Q2, and we're going to get the area of that rectangle instead. Now, you may not be able to tell exactly, nor can I, but it is true that this second blue rectangle, the area of that, is bigger than the smaller red rectangle. And that means that revenue is rising as we move to the right, downward along the demand curve in the elastic section of the demand curve. Okay? So revenue rises along this segment. But then we get to the midpoint here. And when we get to the midpoint, the price is going to be PM, and the quantity is going to be QM, and the revenue is going to be given by the area of this rectangle here. Okay? And that rectangle is now going to be actually the biggest area that we could derive or get from this particular exercise. So at this point, revenue is maximized. Revenue is going to be at a maximum when you're at the midpoint of a linear demand curve. All right, well then what happens next? If we move down further and further, and let me clean this up a little bit. When we move down further to this price, call it P4 and Q4, because I don't know what number I had last, then the revenue is going to be given by the area of this rectangle here. And notice that that's a much smaller rectangle than this one here. So what's going to happen is that revenue will fall as we move down to the right along the linear demand curve when we are to the right of the midpoint. Stated another way then, what it means is that when demand is elastic, revenue rises with decreases in prices in the elastic range of the demand curve. And when demand is inelastic, revenue falls, again, with decreases in prices or increases in quantity. Again, moving down and to the right along the demand curve. So those relationships you need to know, and it might be applied in various circumstances going forward. All right, next. All right, I just want to, this is a really quick graph, and I just want to sort of get at, again, kind of what we're getting at when we talk about elastic and inelastic demand. When we look at a demand curve and we see its shape on a particular diagram like this one, if the demand curve is really, really flat, drawn really flat, then we're going to say that we have elastic demand in that particular area. And based on what we just said before, notice that this demand curve is going to intersect at the price there. And if we were to ask, well, where is this demand curve, like where is the midpoint of this linear demand curve? And the answer is that the midpoint is way out there to the right somewhere. Right? It's going to be halfway down here, and it's going to be way out here somewhere. All right, which means that if we're in this flat segment of the demand curve here, we are to the left of the midpoint, and therefore we have to be in the elastic range of that demand curve. So a very flat demand curve is extremely demand sensitive to changes in prices. Change the price just a little bit, and you're going to get a big increase in demand, right? And that's because we're to the left of the midpoint, and that's how we would reflect an elastic demand. What about inelastic? Inelastic is a very steep demand curve when drawn on a diagram. So if we've got a steeply drawn demand curve, we're talking about an inelastic setup. All right, and here we can see again, this demand curve is going to intersect the quantity axis here, but where's the midpoint? The midpoint is going to be found way up there. Okay, and that means we must, at a point like this, on a very steep demand curve, we must be in the inelastic segment of the demand curve. All right, so this is another association you should take away from this lecture today. Flat demand curves, elastic demand. Steep demand curves, generally inelastic demand. And that's where that comes from.